Okay, this is our Math 6 greatest common factor lesson. Our objectives, I didn't finish writing the second one, but we have two objectives. One is we're going to learn how to find the greatest common factor of two numbers by listing the factors of each number. And the second way is we're going to learn to find the greatest common factor of two numbers. And I didn't finish it, but it is by using the prime factorization. So by using prime factorization. And we already learned about prime factorization before, of two numbers by prime factorization. G, greatest common factor, is often just labeled as GCF. So if you see GCF, that means greatest common factor. Okay, what is a Venn diagram? You've probably seen this in elementary school, but if not, here's one. You can look at some newspapers or articles, and you can probably find lots of examples of Venn diagrams in the real world. A Venn diagram uses circles to describe relationships between two or more sets. The Venn diagram shows the names of students enrolled in two activities. Students enrolled in both activities are represented by the overlapping of the two circles. You can see in this particular example that there are all of these people: Nicole, Joel, Jean, Melissa, Megan, Louis, Abby, Amy, Carlos, Frank, Phil, and Nancy, that are all in the debate team. Everybody in this blue circle is in the debate team. Okay, all of those kids. Over here you have the red, in the red circle you have the swim team. So everybody in this swim team, or in this circle, is on the swim team. But notice there's some overlapping. So these guys right in the middle here, those guys, Louis, Abby, and Amy, they do both. So this Venn diagram is helpful because you can see how the two sets of kids overlap. Another example of kids here at Bell. So there could be some kids that have band, right? You might have band. Then there could be some kids that have STEM, or they have engineering as their elective, right? And to be honest, there could be some other kids as their elective that have FACS, facts, family and consumer studies. So it's possible that we could have some kids that have both band and STEM. Okay, I'm going to change my color here to green, and they could be these kids in here. So some kids could have both band and STEM as their elective. Some kids could have both facts and band as their elective. And some kids could have STEM or engineering and facts as their elective. So this would be a way that we would show in real life, use a Venn diagram at our school. Okay. So we're going to use Venn diagrams to talk about what greatest common factors are. What are greatest common factors? What does it even mean? So what we're going to do is we're going to make a list of the factors, of all of the factors of 36 and of 48. And then we're going to put them in this Venn diagram. So factors of 36. I know 36 and 1 is one way to get to 36. It's an even number, and we learned that by our divisibility rules that 2 then will be a factor of it. So 2 times what equals 36? 18. 3 is 3. Well, I'll know if 3 is by my divisibility rules. Remember, if I do 3 plus 6, if I divide the two or add the two digits together and I get 9, and that's divisible by 3, so then it is divisible by 3. But what will it be? Well, 36 divided by 3. 30 divided by 3 is 10, and then 6 divided by 3 is 2, so I know it's going to be 12. So 3 times 12 will be 36. What is there any other factors of 36? Let's see, how about 4? Is 4 a factor of 36? If I do 36 divided by 4, I would get 9. So 9 times 4 is 36. 5, so we've done 1, 2, 3, 4. 5 cannot be because it's not ending in a 5 or 0. That's why we did our divisibility rules. 6, can it be 6? Is this divisible by 6? So 36 divided by 6 It is, and it happens to be 6 times 6. So 7, now we start going the other direction. Can it be 7? Can you divide 7? Does 36 divide evenly by 7? And the answer is no, it does not. So we're going to erase that. How about 8? Does 8 divide evenly by 36? Or can you divide 36 by 8 evenly? You cannot. So we're going to erase that one. And now we're up to 9, and there's already a 9 here. So this is all of the factors of 36. I've listed all of the factors. I'm going to switch colors to a slightly different color green, and I'm going to list the factors of 48, because that's the one in the other circle. So 48. 48 and 1. It's an even number, so I know 48 is going to be divisible by 2. So I will have to divide 48 by 2, and I would get 24. And that might take you some time. You might have to do some long division like this, right? You might have to do 48 divided by 2 goes in 2 and then 4. So 24. Whoops. So 24. 3 is 48 divisible by 3? I'll know by doing more of this. Is it divisible by 3? 3 goes into 4 once. 3 goes into 18. So it is divisible by 3, and it's 3 times 16. Does 4 go into 48? Well, this one you might be able to do without doing long division. You might be able to do it without the long division. So let's see. 4 goes into 40 10 times, and 4 goes into 8 2 times. So it's going to be 14 times. 5, is 5 divisible? It's not, because it doesn't end in a 5 or end in a 0. So that one's not. And so that's not 5. How about 6? Can 48 be divided by 6? Well, let's see. 6 doesn't go into 4, but 6 does go, well, 6 does go into 48 8 times. 8 times 6 is 48, so you have to know that that's 8. And how about 9? 9, will 9 go into 48? There's nothing times 9 that will equal 48, so that does not. 10, it's not an even number, and now we're at 11. It's not divisible by 11, and now we're back to going to 1, 2, 3. So now we're back to 6 to our number. So these are all of the factors of 48, okay? So we have listed all of the factors of 36. We've listed all the factors of 48, and we are going to now put them in our Venn diagram. Let's do it in a different color. Let's do it in blue, okay? So 36, the factors of 36 are 36. Anything that's in both, we're actually going to put in the middle. So 36, 1 is in both, so I'm going to put 1 in the middle. 2 is in both, so I'm going to put 2 in the middle. 3 is in both, so I'm going to put 3 in the middle. 4 is in both, so I'm going to put 4 in the middle. Let's see, then I'll just keep going. 18 is only on this one, so I'll put 18 over here. 12 is only on 36, I'll put it over here. 9 is actually in both, right? So I'm going to circle that one. 9 is in both, put it in the middle. 6 is in both, so I'm going to put that in the middle. 4, let's go back over here. 48 is only in the red. 24 is only in the red. 16 is only in the red. 14 is only in the red. And 8 is only in the red. So those are all of our factors for 36 and 48, and we put them in a Venn diagram. Then I'm going to look for which ones are in the middle. Okay, so these ones that are in the middle, that are in both of them, because we're looking for a common factor, means it's in both of them. So a common factor are all of these numbers. Common factors are 1, 2, 3, 4, 6, and 9. So those are our common factors. But our greatest common factors, which one's the biggest? 9. 9 is the biggest. So the greatest common factor here is 9. Okay, that's it. I'm going to erase this down here so we have a little bit more space. And we're going to look at the next set. We're going to look at 16 and 56. So with exactly the same thing, we're going to look at 16 and 56. So the factors of 16, I know 1 times 16, 2 because it's even, and 2 times 8 is 16. 3, 6 plus 1 is 7, so 3 is not a factor. 4, I know 4 times 4 is 16. I don't have to list those twice because just one factor. 4. 5 is not a factor because 5, it doesn't end in a 5 or 0, and we said anything divisible by 5 had to end in 5 or 0, so 5 is not a factor. 6 is not a factor because nothing times 6 equals 16, because 6 is 6, 12, 18. Now we're beyond, and we're back to, there's no 7, because 7, 14, 21 if I skip count, so it doesn't hit 16. And we're all the way up to 8, and 8 is already listed as a factor. So this is a complete list of the factors of 16. Now let's do a complete list of the factors of 56. Okay, 1 in 56. It's divisible by 2 when we learn our divisibility rules. So we would have to figure out what is 56 divided by 2. 2 goes into 5 2 times with 16 left over. 2 goes into 16 8 times, so 28. So 2 times 28. 3 is 56 divisible by 3? I know it's not because 5 plus 6 equals 11, and that's not divisible by 3. So it is not divisible by 3 because I learned my divisibility rules last week, right? We worked hard on that. So, not 3. How about 4? Is 4 1? So is 56 divisible by 4? Something times 4, will it equal 56? Four goes into 5 one time with 1 left over, carry down the 6, and 4 goes into 16 4 times. So I know I'm doing this fast, and I'm going through the thought process pretty darn fast, but that's okay, because this is a video. You can stop it and you can think about what I'm saying. How about 5? How about 5? Does 5 go into 56 evenly? It does not, so I'm going to erase that. It doesn't go into it because it doesn't end in a 5 or 0, and we learned that's the divisibility rule. How about 6? Does 6 go into 56 evenly? Does 6 go into 56 if I try to divide that? Is there anything times 6 that I can multiply by and get 56? There is not. So 6 is not 1. So we're going to back it up there and say 6 is not 1. How about 7? Is 7 1? Is there anything I can multiply by 7? Let me try it with skip counting. 7, 14, 28, 35, 42, 49, 56. 56 divided by 7 is in fact 8. So 7 times 8, those are both factors of 56. Okay, I can keep skip counting. It's also a way to do it. Let's go to 9. Is 9 a factor of 56? Is there anything times 9? So if I skip count 9s, I get 9, 18, 27, 36, 45, 54, 60. Oh, I'm over it. So 9 is not 1. So I'm going to take off the 9. 10 will not be 1 because it is not ending in a 0. 11 is 56. Can you put 11 into 56 evenly? Is 56 divisible by 11? It is not, so not 11. These are all the factors of 56. So now we're going to put them in our Venn diagram, just like we did before. So factors of 16, they both have 1, so that one goes in the middle. They both have 2, so that one goes in the middle. They both have 4, so that one goes in the middle. They both have 8, so that one goes in the middle. 2, 4, or 1, 2, 4, and 8. Only the 16 has 16, so we're going to put 16 over here. Only the 56 has 56, so we're going to put 56 over there. Only the 56 has 28. Notice I'm just kind of marking them off as I go so I don't forget them. 14 and 7. So the common factors of 16 and 56 are these 4 numbers that we put in the middle. Those are the common factors. 1, 2, 4, and 8. The greatest common factor is the 8 because that's the biggest one. So the greatest common factor, the GCF, is 8 of 16 and 56. All right. Next topic. That's hard to do. It's hard to write down all of those factors. This way might be easier for you. If I have to choose between them, I'm going to choose the second one, but you have your choice. Do you like to write down all the factors and then see which one is the greatest? And you don't have to put them in the Venn diagrams. Or would you rather put them in or would you rather do prime factorization? Let's see what prime factorization looks like. I like this one. This is my favorite one for sure. So 36, I know it's even, so I'm going to do 2 and 36 divided by 2. Well, half of 30 is 15, and then half of 6 is 2, there's 3 of those. So 15 plus 3 is 18. That's how I think of it when I'm doing my division in my head. 18 I know is also divisible by 2, so I can do that again. 2 times 9 is 18. 9 is not a prime number because 3 times 3 equals 9. All of these numbers that are left, 2, 2, 3, and 3, are all prime numbers of 36. Those are the prime factors of 36. Let's do this one in blue. 48. Prime factorization of 48 is 2 and 24. 24, I could either do 2 times 12 or 3 times 8, whichever you like. We'll do 2 times 12. 12 is divisible by 2 also, 2 times 6. 6 is still not a prime number, so we get 2 times 3. So this is our factor tree where 2, 2, 2, 2, and 3 are all prime factors of 48. Now, here's where we get to go with a different color. I'm going to go purple. Each time that the factor is in both trees, we're going to list it. I'm going to write it down as part of a multiplication problem. So here's a 2, here's a 2, here's a 2. Here's a 2, here's a 2, here's a 2. I don't have another 2 over here, so I can't use that 2, and I can't use that 2 because there's not a 2, but there is a 3 still in both. I put multiplication sign in between there. So I multiply whatever's the same. So there were 2 2's that were the same, and then there was a 3 that was the same. So 2 times 2 times 3. This is how you find the greatest common factor. 2 times 2 times 3. 2 times 2 is 4, and then times 3 is 12. So the greatest common factor between 36 and 48 is 12. Okay? So that's one way to do it. The other way was listing all of the factors. I like this way better because I just feel like you're less likely to make a mistake. If you can get this part down where you're making these factor trees down to the prime numbers, that's huge. Do that, and then the rest of it's easy. So make the factor trees, draw a little, be a little creative. It's kind of fun. So we're going to try 2 more examples both ways before we move on. There are 2 ways to find the GCF. List all the factors, and so our example here is find the GCF, greatest common factor, of 36 and 54. Did we do 36 and 54? We did not. Okay, 36, the factors of 36 are 1 and 36. I'm going to put it out here so they're already in order. 1 and 36, 2 and 18, 3 goes into 36, well, 10, 11, 12 times. 4 goes into 36. We actually already did this, but they're right here. Oh, no. They're right here. Oh, we already erased them. They're right here. So 36, 12, 8, so 1, 3, up. Anyway, it's hard for me to see all that. 5 is not 1. 6 is 1 because 6 times 6 is 36. 7 is not 1, we said. 8 is 36 divisible by 8. It is not. Is 36 divisible by 9? It is. So those are all our factors of 36. 54. What are your factors of 54? I think we did this one too. It sounds familiar anyway. Maybe we didn't. Okay, so let's do our factors of 54. We've got 1 and 54. 2 and half of 50 is 25, half of 4 is 2, so 27. 3 is a factor of 54 because 4 plus 5 is 9, and that's divisible by 3. So 54 divided by 3. 54 divided by 3. 3 goes into 5 one time with 2 left over. 3 goes into 24 8 times. So 18. Is 4 a factor of 54? Is 54, divided by 4. 4 goes into 5 once with 14 left over. 4 does not go into 14 evenly. So, therefore, 4 is not 1. How about 5? 5 is not 1. 5 is not 1 because 54 does not end in a 5 or 0. How about 6? Is 6 1? Does 54, can you divide 54 by 6? Is there anything that you can multiply by to get to 54? Well, let's skip count our 6's. Let's do it that way instead. Let's show a little bit of what we could do. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. So we passed over 56. So 6 is not, when I skip count, 6 does not get me to 54. So 6 is not a multiple of 54. How about 7? Skip counts up to 7s. 7 is not 1. How about 8? Is 8 1? Skip count. 8, 16, 24, 32, 46, 54. I don't think I did that right. I made a mistake. 8, 16, 24, 32. Oh, 32 does not go to 64. Let's fix that. 32 plus 8 is 46. And then plus another 8 would be, 32 plus 8 would be, oh my goodness. 32 plus 8 would be 42, plus another 8 would be 50, plus another 8 would be 58. So we skip right over 54. So 8 is not a factor. If you already know your multiplication, you don't have to go through these quite as slowly as I am. If you can write down what the factors of 54 is, that might be all you need to do. You don't have to go quite as slow as I am. I also know that 6 times 9 is 54. So those are my factors of 54. My greatest common factor, I'll go ahead and circle in red, is my greatest common factor is 18. I can't get to 36. I can't get any higher anywhere. So 18 is the GCF of 36 and 54. Okay? Ooh, that's a lot of work. Let's try it the way I think is easier. Okay, we're going to do it this way. 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. Those are all prime numbers. There's nothing I can multiply to get any lower. It's as low as my branches will go. 48, 2 times 24. 24, 2 times 12. 12, 3 times 4. Now, in another color, get a highlighter or get some other color that you have. Let's do purple. We're going to cross out a 2 and put a 2 in our multiplication. So 2 times. Here's another 2. There has to be, you have to cross out 1 from each number. I can't cross out this 2 right here because there's not a 2 over here. I can't cross out this 5 because there's not a 5 over here. I can't cross out this 3 because there's not a 3 over there. And I can't cross off a 4 because there's not a 4 over there. So 2 times 2 equals 4. So 4 is the GCF of 40 and 48. So much easier to me to use the prime factorization method than it is to find all of the factors and then find the greatest of them. This is good, but this way is much easier. So I highly recommend you try that one. This is the end of our video. I hope it sort of makes sense to you. Those are two big things, but knowing how to find the greatest common factor is a huge skill that we will be learning in 6th grade. We will have more practice on this in the next few days, so don't stress. We're going to keep practicing it till we get it, okay?